Good afternoon. My name is Gregory. Today we will be working from the Headway Upper Intermediate book, and we will go to page 98, where we will have a look at some interesting topics that I'm sure we've all wondered about on occasion. And in this lesson we will be looking at some of these interesting topics and talking about them. The first one we are looking at is, why do we dream? Now, it's a fact that whether we remember them or not, every night when we sleep, we all dream. There are different stages of sleep that we go through, and as we go through those stages, there are different stages where we dream. Scientists can tell exactly when we are dreaming because we have what they call rapid eye movements. That is where our eyes flicker backwards and forwards very quickly while our eyes are closed, almost as though we are watching the action in our dream. So let us read what they say here about dreaming. Why do we dream? What is the purpose of dreaming? I'll read the first paragraph. Two different schools of thought exist as to why we dream: the physiological school and the psychological school. Both, however, agree that we dream during the REM, R-E-M, or rapid eye movement phase of sleep. During this phase of sleep, our closed eyes dart rapidly about and our brain activity peaks. This is what I was saying earlier, that when we dream, our eyes move very rapidly back and forth. They talk about two different schools of thought that exist as to why we dream: physiological and the psychological. Physiological is to do with our physical body, our physical brain, and physical processes within our body. Psychological school is to do with the thought processes that go on in our mind. Let us look at these two schools of thought in more detail. The physiological theory centers upon how our brains function during the REM phase. Those who believe this theory say that we dream to exercise the brain cells. When awake, our brains constantly transmit and receive messages and keep our bodies in perpetual motion. Dreams replace this function. So what they are saying is the physiological theory is believe that we dream in order to exercise the brain cells. Because while we are awake, our brains are constantly transmitting and receiving information. When we sleep, obviously that transmission and receiving of information slows down. And therefore, according to this theory, we then dream so that our brains continue to be exercised. Psychological theorists of dreams focus upon our thoughts and emotions and say that dreams deal with immediate concerns in our lives, such as unfinished business from the day. Dreams can, in fact, we will come back to that. Connections between dreams and the human psyche have been made for thousands of years. The Greek philosopher Aristotle wrote in his Parva Naturalia over 2,200 years ago of a connection between dreams and emotional needs. So the psychological theory focuses upon our thoughts and emotions. And the one school of thought tells us that dreams are dealing with unfinished business of the day. So if you had a particular problem that you were facing or dealing with, and you did not get it resolved during the day, in your dreams you will dream of it in some form or another, and in that way, hopefully, deal with the issue that you are struggling with or dealing with. So I hope that gives you some more thoughts about what dreams are all about. I don't think they've ever been really fully understood, but there are a lot of theories, and it's very interesting to think about it. Now, what are falling stars. You know, if you go outside at night and you look up at the night sky for long enough, eventually you'll see flashes of light, streaks of light coming down out of the atmosphere, or apparently from outer space. What are those flashes of light that we see? In fact, at the moment we are going through a period of high activity in the night sky, where there's a lot of, if you go outside at night, you'll see maybe 2 or 3 flashes every minute. What is that all about? Contrary to popular belief, falling or shooting stars are not stars at all, but meteors, solid bodies that travel through space. Meteors, and we'll come back to that, to huge objects weighing many tons, which are visible to the naked eye at night. Most meteors, except the really huge ones, burn up when they enter the Earth's atmosphere. If they do and land successfully, they are renamed meteorites. So what we have in outer space are specks of dust, space dust, stones, fairly small stones, and some really huge, large chunks of rock or other matter. When they pass close to the Earth, Earth's gravity attracts them and pulls them down. When they reach the atmosphere, they are known as meteors. As they travel through the Earth's atmosphere, they are accelerated more and more by the gravity of the Earth. And as they are coming through the atmosphere, through the air surrounding the Earth, they warm up from friction, from rubbing against the air molecules. And they get hotter and hotter until they glow white hot, and that is when you see this flash in the sky. As they burn up, as they get so hot, they become white hot. However, some of them are so large that they do not burn up at all, or they do not completely burn up in the atmosphere, and they actually come crashing down to Earth. In fact, there's one theory that said that is what wiped out the dinosaurs on Earth, was a very huge meteorite that crashed into the Earth. It raised a lot of dust and debris into the atmosphere. It changed the climate of the whole Earth, and that led to the extinction of various animals. To continue, usually meteors travel together in swarms like bees. NASA's spectacular fireworks show, a meteor shower, comes into view when these swarms hit the Earth's atmosphere and then fall towards the Earth in a brilliant display of light. One must be quite patient to witness the most spectacular meteor storms, as these cross the Earth's path only once every 33 years. So there are no meteor storms in outer space, and as the Earth travels around the Sun, it passes through some of these clusters of meteors, and as it passes through, they get attracted by the Earth's atmosphere, the Earth's gravity, fall through the atmosphere, give a brilliant flash of light, but you need to be patient if you want to see this. At different times of the year, or different times of the year are better for seeing meteorites than other times. What I would suggest you do if you really want to see the meteors, especially here in Saudi Arabia, is go out to the desert for the night. Take something comfortable, take some food, take something to drink, and just lie back and look at the sky. It is very clear out in the desert. There's very little pollution or atmosphere or light pollution. So if you look up at the sky, you will see the stars, and you will almost certainly, if you are patient, see a meteor or even a meteorite. There's only one recorded instance of a person being hit by a meteorite. I think it was in the 1930s. A lady in America was lying on the couch watching TV, and a meteorite came crashing through the roof of her house, through the ceiling, and hit her in the abdomen. And if you go onto the internet, you can actually see pictures of the injuries that were done. She survived, she was not seriously injured, but she has the unique record of being the only human being to be hit by a meteorite, although hundreds of them do hit the Earth every day. I hope you found that interesting. Is it something you've ever thought about, something that you've wondered about? Let us now have a look at something else. Something that we take very much for granted is gravity. Gravity is what keeps us on the Earth, that stops us from just floating away into space. It is also what determines how much we weigh, what is our mass on Earth. It is a force of gravity pulling us down towards the center of the Earth, and this force is dependent on the size of the body. So if you on Earth weigh, for instance, 70 kilograms, on Mars, which is a smaller planet, you would probably weigh only 50 kilograms. Or if you went onto the Moon, which is much smaller than the Earth, you would weigh maybe 10 kilograms. Which means that if you had to go onto the Moon and jump, instead of just going that high, you would maybe go up 10 or 15 feet and then slowly come back down again, because the gravity is much less on the Moon. So the question we ask here in number 3 is, what would happen if the gravity on Earth was suddenly turned off? Let us see. Supposing we could magically turn off gravity, would buildings and other structures float away? What happens would depend on how strongly the things were attached to the Earth. The Earth is rotating at quite a speed. Number 3, we will come back to that. If you could spin something around your head on a string that goes around in a circle until you let go of the string, then it flies off in a straight line. Switching off gravity would be like letting go of the string. Things not attached to the Earth would fly off in a straight line. People in buildings would suddenly shoot upwards at a great speed until they hit the ceiling. Most things outside would fly off into space. Some things, like trees and many buildings, which are rooted into the Earth, would not find it so easy to fly off. So if you think about it, we stand on the Earth, and the force of gravity keeps us rooted to the Earth, fixed to the Earth. It is also the gravity of the Sun that stops the Earth from flying off into outer space. We go around in a circle because the Sun's gravity is balanced by the speed of the Earth's movement. So we go around in a pretty much elliptical orbit around the Sun. So if the Earth's gravity suddenly came to a stop, or suddenly switched off, we would all, because the Earth is spinning at a high speed, we would fly off into space. We would just, anything not fastened to the Earth or anchored to the Earth, would just simply take off. It would go flying off into space. So gravity, although we might complain about how much we weigh on Earth, gravity keeps us alive. It is very necessary, and it is the most universal force in the universe. Have you ever wondered, why do aeroplanes take longer to fly west than east? Did you even know that it takes longer for aeroplanes to fly west than east? I did not know that. So let us read what they have to say about that. It can take 5 hours to go west-east from New York to London, but 7 hours to travel east-west from London to New York. Now, isn't that fascinating? The reason for the difference is an atmospheric phenomenon. The jet stream is a very high altitude wind which always blows from the west to the east across the Atlantic. The planes moving at a constant airspeed thus go faster in the west-east direction when they are moving with the wind, and in the opposite direction. Atmospheric means to do with the air that surrounds the Earth. Phenomenon is a wonder, something that happens, an observable event. So the reason it takes longer to go west-east is because of very high-speed winds high in the atmosphere at the altitude at which aeroplanes fly. So flying in the one direction, the west-east direction, they are flying against the wind, which is blowing at several hundred kilometers. It's a very high-speed wind. And when they fly the opposite direction, they are flying with the wind, which gives their speed a boost. And now, as I said earlier, let us have a look at what would happen if there was no dust. I think living in Rio, we would be very happy, or we believe we would be very happy if there was no dust. Especially when you have dust storms and you have to wear a face mask to keep the dust out of your mouth and out of your nose. But what would happen if there was no dust at all? Most of us who have ever cleaned a house would be much happier if there was less dust. However, without dust, there would be less rainfall and sunsets would be less beautiful. Now there's a fascinating thought. There would be less rainfall. Why would that be? Rain is formed when water molecules in the air collect around particles of dust. When the collected water becomes heavy enough, number 5, we'll come back to that, but it will say the water falls to earth. Thus, water vapor would be much less likely to turn to rain without the dust particles. So without dust particles, the water vapor would have nothing to collect against. Without the dust, the water molecules would have nothing to collect around, and so they would just stay up as clouds in the sky. The water vapor and dust particles also reflect the rays of the sun. At sunrise and sunset, when the sun is below the horizon.
Teacher, what's the water molecule? What's this molecule? What's that?
A molecule is the smallest particle of any substance. So a water molecule, if you took a drop of water and you cut it in half, and you split it in half again and again and again, eventually you would get to a point where you could no longer cut through it. You could not divide it any further. You would then have one molecule of water, which is two atoms of hydrogen and one atom of oxygen, which is H2O.
Teacher.
Yes, Paul.
What's a particle of dust? What's that?
That would be, dust is not just one substance, it is many things. It could be sand, it could be impurities in the air. There are many things that we just simply lump together as dust. So a molecule of dust would be the smallest piece of whatever it is that you see on your floor that you want to sweep up. But it'll be the tiniest particle possible to have of that particular thing. If it is sand, if you think of one grain of sand, cut it in half, and keep on going, cutting it, until you cannot go any smaller. That will be one particle of dust.
So, teacher, can we say water particles?
You can say water particles. But there are particles of water which are very small measures of water. It is not a molecule. A molecule is the very smallest that there can be. A particle could be a collection of several molecules that have clumped together.
So can we say dust molecule?
You can have a dust molecule as well. But that could be many different things, because dust is not just one particular substance. Anything that you see that collects in the corner of your house or in the corners of a room that you sweep up or you vacuum up, we call dust. But it can be little mites that animals give off. It could be dust, it could be dandruff. It can be a whole variety of different things. So yes, you can say that you have molecules of dust, but you don't know exactly what you're talking about, because dust is a very general term.
So, teacher.
Yes, Paul.
What is water vapor? What's that, vapor?
Water vapor is, water can exist in 3 different forms: as a gas, as a liquid, or as a solid. As a solid, we call it ice. As a liquid, we call it like a glass of water, or the ocean, or a lake, or a dam. And as a gas, it is a vapor. In other words, it is, if you take a lump of ice and you heat it up, it will melt and become water. If you continue to heat it, it will become a gas and go into the air and become invisible. Be aware, steam is not a gas. Any other questions, Paul?
No, teacher, no questions.
And I'm sure as we go along, you will think of more. So the water vapor and dust particles also reflect the rays of the sun. At sunrise and sunset, when the sun is below the horizon, the dust and water vapor molecules reflect the longer red rays of light in such a way that we can see them for more time. The more dust particles in the air, the more colourful the sunrise or sunset. So when you are outside, maybe in the desert or sitting at the ocean somewhere, and the sun has just set, you'll see that the sky is red in the east or the west. That is the sun shining on dust particles and water particles in the air, and they are reflecting the red light, and that is what makes it look so beautiful.
So, teacher, what's the difference between sunrise and sunset?
Sunrise is at the start of the day when the sun comes up from the horizon. Sunset is at the end of the day when it goes down and disappears again below the horizon. Sunset is the end of the day, sunrise is the start of the day.
Okay, teacher.
Now, let's look at something completely different.
What's that? Monty Python's?
What is the origin of the @ symbol? You've all seen that one. If you've ever written an email or received an email, you will have seen the @ symbol. It is somebody's name at gmail.com or at yahoo.com or at hotmail.com. But where does that come from? Have you ever wondered? Let us have a look. History tells us that the little @ in email addresses, commonly referred to as the @ sign, stemmed from the tired hand of medieval monks. During the Middle Ages, before the invention of printing presses, every letter of a word had to be painstakingly transcribed by hand in Latin for each copy of a book. Painstakingly means carefully and slowly, to make sure there were no errors or no mistakes, and it was very clear. The monks that performed these tedious, very similar to boring. The monks that performed these tedious copying duties looked for ways to reduce the number of individual strokes for common words.
Teacher.
Yes, Paul.
So, can we say a tedious film?
You actually can. You could say you were sitting in the film, and tedious means it just went on and on and on, and it didn't seem to have any point or be going anywhere. So you would say it was very tedious.
So, can we say a tedious game of cricket?
Very definitely you could, especially if it's a 5-day game, and the team who's batting just wants to make the game last so they could play for a draw perhaps. So they will play a very tedious game of just blocking the ball all the time, not attempting to get any runs, not taking any chances. And to watch such a game would be very tedious indeed.
But teacher, could we say a tedious teacher, for example?
You wouldn't refer to a person as tedious. You would refer to the teacher as boring, and his lessons are very tedious. They just sort of go on, and he doesn't move around, he doesn't change the tone of his voice, he just stands there and talks the same way all the time and just reads from the book and doesn't really do anything, and you wonder what the hell are you doing here at all. That would become very tedious, and you would just want to get out.
So, teacher, are you likely to change your method of teaching then?
I think that, I need to try. Although the word ad, the Latin word for at, is quite short, it was so common that the monks thought it would be quicker and easier to shorten it even more. As a result, they looped the D around the A and eliminated 2 strokes of the pen. With the introduction of email, the popularity of the at symbol grew. For instance, Joe at uselessknowledge.com. There is no one universal name for the sign. But countries have found different ways to describe it. Several languages use words that associate the shape with some type of animal. These include snudder, Danish for elephant's trunk; klammeraf, German for hanging monkey; papaki, Greek for little duck; kukak, Hungarian for worm; dalferengi, Korean for snail; Norwegian for pigtail, or Russian for little dog. So there's all different words in different languages that people use to describe at. So I hope you've had a look at these various things, and I'm sure at least some of them you have wondered about. And I hope you've learned something, and I hope you have found the lesson interesting. Thank you for your time and attention, and I will see you next time.